Welcome, ladies and gentlemen, along with some fine AP Chemistry students. I'm glad you're here. My name is Renee McCormick. I'm with the National Math and Science Initiative, and we are still trudging our way through net ionic equations. This will be the shortest section of them all. That is good news. Well, unless you're at the beginning, in which case it's probably a little depressing. But if you've been trudging your way through redox, this is excellent news. So here we are with decomposition reactions. This is something that you weren't introduced to in first year, but we're going to put a finer bit of touch to it and master some common concepts that are actually going to translate into a lot of multiple choice points for you as well. So here we have compounds that are going to break into two or more elements or compounds, and heat, electrolysis, or catalyst is what's usually necessary for this to happen. And remember that you write a catalyst above the arrow. It's not a reactant, nor is it a product, so it lives above the arrow. If you did it below the arrow, it's not the end of the world, but most books do it above. So a compound can break down to produce two elements. So we can melt sodium chloride and then run an electric current through it if we want to get back to the elements sodium and chlorine. So be on the lookout for salts. I know you think of this as the only salt in your life, but there are many, many salts. Salts are simple combinations of metals and nonmetals. So be on the lookout for them. If we run a current through them, they may say melted. This one says molten, which means melted. So they may say that, they may not. They may just say they're running an electric current through. If it's in solution, you're also going to have to be on the lookout for hydrogen gas and oxygen gas, because we can electrolyze water as well. All right, so a compound can break down to produce an element in a compound. This is our classic. Hydrogen peroxide is decomposed catalytically. Sun, light, are my catalyst on that, not sunlight necessarily, but sunshine, sunlight, or just plain light, even in a room. That's why we store it in a brown bottle. So we're going to make water and oxygen, and of course you'll have to balance it. We can also have a compound break down to produce two other compounds. So solid magnesium carbonate. This one is classic. Any metal carbonate will release the CO2, but will leave behind an oxide. So the remaining oxygen out of that CO3 2- polyatomic ion stays with the metal to make the oxide of the metal plus carbon dioxide. So not a whole lot to master on this. This one, like I say, is pretty easy. As I just said, metallic carbonates break down to yield metallic oxides. Don't forget the oxide part, and carbon dioxide. Metallic chlorates break down to yield metallic chlorides and oxygen. And then hydrogen peroxide, like we said, over and over, decomposes into water and oxygen. Ammonium carbonate decomposes into ammonia, water, and carbon dioxide. Sulfurous acid is going to decompose into water and sulfur dioxide, while carbonic acid decomposes into water and carbon dioxide. So think about what these are. That one you know, without a doubt, but this is SO2. And this is CO2, and sulfurous acid is H2SO3, and carbonic acid is H2CO3. Get the pattern? So I like it when you kind of get two items for one memory expense, shall we say. I don't have a lot of examples. This is going to go fast. That means you can rewind and listen to it again and again if I lose you at any point. A solution of hydrogen peroxide is heated. So I don't know how many different ways we can say this is going to decompose. A lot of times we put a triangle above the arrow for to show heating. I always thought of it as like, as sad as my artistic ability is, a sad attempt at drawing the flame of a Bunsen burner. So H2O2 make water and oxygen, and then balance the equation. So there's a lot of O over here, so it's going to force me to double this, and if I double that, I get 4 H's on each side, and I have 4 waters on each side, and we're golden. That's a fast one. This is gas, so all sorts of questions can be asked about that in terms of the qualitative things, like how hydrogen versus oxygen behave in the presence of a flame. Oxygen is very flammable. A burning splint inserted into a test tube will make it flame up again, etc. And then moving on, we have solid magnesium carbonate, MgCO3. Mg is from the 2 A's, and carbonate's a 2- ion. Can't help you if you don't know your ions. I can do a lot for you. Memorize stuff for you is not one of those things on my list. So we're going to leave behind the metallic oxide, MgO. Make sure you get a right formula. And CO2, gas given off. And it comes balanced. Doesn't get much easier than that, folks. A solution of hydrogen peroxide is catalytically decomposed. Oh, okay. Maybe this is important if it keeps showing up over and over again, huh? Gonna have to double both of these. And again, that's oxygen gas. Solid potassium chlorate, so don't even think about it, just write it down as KClO4, is heated, again with the little flame, in the presence of manganese dioxide as a catalyst. MnO2 also goes above that. And so what are we going to make? Well, this is one of those metallic chlorates. So you're going to make the metallic chloride, KCl, and this is not in solution. I know you're wanting to ionize that, but read again. Solid potassium chlorate is heated in the presence of manganese dioxide as a catalyst. There's no water in here. So we're going to leave behind the chloride, but what we're really doing is driving off the oxygen. So when we balance that, if we put a 2 there, we have 4 O's on each side, and the rest is balanced. Told you these were easy. Try not to make them hard. And then sodium hydrogen carbonate, you lovingly call it baking soda, is dissolved in water. Just break it apart into the 2 ions. Again, doesn't get much easier than that. Solid ammonium carbonate. NH4 is a +1, carbonate is a -2, so I'm going to need 2 of those. I would have scared you in first year chemistry. Is heated, so we're going to make ammonia. Anytime you're going to heat ammonium, think ammonia is somewhere lurking. It's going to start stinking. We're also going to make water, and we're going to make CO2. This is one of these things that you just memorize. If you heat a carbonate, you make CO2. If you heat ammonium, you make NH3. And we also, as a byproduct, get water out of the deal. So how about balancing this? Well, I'm going to have to force a 2 there because of that 2 right there. So what does that do? That gives me 2 nitrogens on both sides. Cool. 8 H's on the left, 6 in the ammonia, 2 more in the water is 8. 1 carbon, 1 carbon. 3 O's total on the left, 2 for this, 1 for this, 3 total. We are done. That is the fastest recording I've ever made. I know I'm your new best friend now, so go forth, gather some points, and have a great rest of your day. You have time to listen to a different Net Ionic recording. Oh, but before I leave you, this is the practice site right here. If you are still struggling and the recordings aren't helping you, and you do have your polyatomic ions memorized, you have memorized some of the little statements and hints that we give you in this set of lecture notes, then try this. Try going out here and just practicing. You are capable of learning. I have faith in you. It's just a matter of repetitions. Have a great rest of your day. Be safe.